Hello everyone, thank you for checking out my video, and today we're looking at congruent triangles and how to prove that a triangle is congruent. So the first thing I want to talk about is, what is a congruent triangle? Well, a congruent triangle is similar to what we've done, congruent shape in general, similar to what we've done in previous videos when we was talking about rotation, reflection, and translation, where we make a whole new figure and we move that figure around. Now we have two figures, but the size and the shape of the figure is exactly the same, so that they can overlap on each other and fit perfectly. Okay, so what we're talking about today is if with triangles, or with any shape, if all the line segments and the angles that correspond with each other are congruent or have the same shape, then the whole shape itself is congruent. Okay, now there are some proofs and theorems and postulates that you could use to prove that triangles are congruent without knowing every angle and every side is congruent. So here are some theorems and postulates that you want to write down so that you know. You've got angle, side angle. You've got angle, side. And then you have side, and side, angle, side. And I'm about to go into detail on each one, but I just want to show you what they are so you can see them, write them down, match the name with the picture, and get a sense of what type of triangle it is before we move forward on those. Okay, so now I'm going to talk about each one of these individual, and then I'm going to talk about some that is not will not tell you there's a congruent triangle. Okay, so let's take a look here. Alright, so the first one we're going to look at is side. Okay, and with side, what they mean is if each side that corresponds, and let me put some letters with these. Let's say you got A, B, C, and X, Y, and Z. Okay, now the line segment from A to B, let's say it's 5, this is 8, and I'm just making some numbers up, it's 10. And these little marks let you know that they're congruent, and the actual measurement lets you know it's congruent. So the line segment A to B is 5. The line segment from X to Y would also be 5. The line segment from X to Z will also be 8. The line segment from Y to Z is 10. And these line segments correspond with each other. Well, this 8 and 10 won't match because you can tell this looks longer, but let's not focus on that. So my whole point is, if you got 3 corresponding sides, and that means that the whole triangle is congruent. That means that angle A is going to be congruent to angle X, angle B is going to be congruent to angle Y. Every corresponding part is congruent, and then the whole shape is a congruent triangle. And you can prove it as soon as you find out that all 3 corresponding sides are congruent. Alright, let's take a look at another example. Okay, so in this example, this was called angle, side, angle. Okay, and with angle, side, angle, we're looking at, and I'm gonna put some letters on this one too. So I'm gonna put some letters on that. Let's see, black. A, B, C, and X, Y, and Z. Okay, so they got this funny looking curve here. Usually what happens is you get 2 curves, just like you get 2 tick marks. Okay, so what we're saying here is that if you have a angle, side, and angle, and that side is included in between the 2 corresponding angles, then you also have an angle, side, angle. And then that's enough to prove that the whole triangle and all its corresponding parts are congruent. Angle, side, angle. Alright, let's look at another one. Alright, this one's side, angle, side. And the way the letters are is exactly how it should look on your shape here. So side, angle, side is another one. So the angle has to be included in between the two sides. Okay, so if I zoom in here, and you can see, and if I that this angle, you got this, let's see, put some letters on here, A, B, C, X, Y, Z. Okay, so we know from A to B, X to Y, you got A to C, X to Z, and the angle in between, angle A, B, C, is congruent to angle X, not angle X, angle Y. Well, I messed this up too. Let me go back and fix it. Angle BAC is congruent to angle YXZ. And that angle's in between the two corresponding congruent sides. And once you have that, then you have angle, side angle. I'm sorry, side angle side. Okay, so those are, oh, and one more. Angle side, okay? So because you have two angles, that side that's in between, you don't have to worry about that, but it has to be a side right after one of them. So here you've got, I'm going to zoom in a little bit, angle, not this side, angle, but then a side right after it. And if you have that, then the whole thing is congruent, the whole triangle. Now I'm going to show you some where you may have them, but it doesn't prove that they're congruent. So let me give you an example of those. Alright, so two of those would be angle, 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 where you got the angles are congruent, but that doesn't make the triangles congruent. So what I'm saying is that this could be 60 degrees, this could be 60 degrees, and this could be 60 degrees, 60, 60, and 60. But you can still have that type of shape where the angle, they don't overlap on each other. Alright? And this shape right here is pretty confusing. Don't even worry about that. But just understand that if your angle's not in between the two sides, and you have side-side angle, that does not prove it congruent. Okay? Now, there's one more that's not in this PDF that I want to show you. Okay? And hopefully I could draw it a little bit. Alright. This may not be perfect, but notice how in this particular shape you have some right angles. If you have a right angle and a leg, let me talk to you about this right quick. So this is a right triangle. In a right triangle, you have two legs and a hypotenuse. In every right triangle, you have two legs and a hypotenuse. Okay? So there's one that's called the Hypotenuse Leg Theorem. Goes right along with side, angle, side, side, and all that. Hypotenuse leg. So if you have a hypotenuse that's congruent and one leg that's congruent, then that's going to make the whole triangle congruent. So that's one to be aware of too. Also another one you want to write down. Hypotenuse leg. Okay, now what I want to do is take a look at some problems and see what they look like and how to get the correct answers for them. Alright, let's take a look. Alright, so here's an example. It says determine the relationship between the two triangles whether or not they can be proven congruent. Okay? And if they fit in one of those 5 categories, side, side angle, side angle, and angle side, then it could be proved congruent. Okay, let me go back here. Trying to make this bigger. Okay, so here we go. So we want to determine whether we want to determine on which one it is and whether it's congruent. So first you look to see if it's one of the five. Well, this one we got a right angle, so we could take a look and go off of is the hypotenuse leg. So we've got a right angle, we've got a hypotenuse, this matching up is congruent, and we got a leg that's congruent. So you got a hypotenuse and a leg, so it's going to be the hypotenuse leg theorem, which pick here, and you say that it is congruent, can be proven congruent. That's simple. Alright, let's take a look at another one. Alright, it says determine the relationship between the two triangles and whether or not they could be proven congruent. Okay, so we're looking at it. Alright, so we've got, and I'm going to see if I can't make this bigger. Control. Shift. Alright. Okay, so let's take a look and see what we got. We've got two angles and a side. Okay, two angles and a side. And if it helps, come back to your notes and look to see. So we go back here. We've got the hypotenuse leg, and we also got two angles and a side. We've got that one as one of them. Two angles and a side. So is that what this one is? Two angles, then a side. Two angles, and then a side. So that's going to be angle, angle, side. And then that's one of my R5, so it can be proven with that. Okay? That's all we're doing here. Let's take a look at another one. Alright. This is another hypotenuse. Let me get another problem. Okay, so here we don't have any information on angles, but we do have information on the sides, and we know all three sides. So with all three sides here, we could go off of our theorem, which is side, side, side. So we go off of that. So we say the two triangles are related by side, side, side. Oh. This one. And then say it can be proven with that. Alright, let's see if we come across one that cannot be proven. Okay, so here we've got an angle and we've got two sides. The angle is not in between the two sides though. Okay, so this would be side, side, angle, right? So let's take a look and see if that's one of our options. Okay, we got side, angle, side, 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 angle, side, angle. This has two angles on both of these, so it's not this one. It's one of the ones that we said it would not be side, side, angle. So you would go with side, side, angle, but then say it cannot be proven. Okay, and this is Triangle Congruence Criteria Level 1. So and this is how you do these. This is all you have to do. And there's some harder ways to do these, but they're not in these problems here. So just make sure you can master this. Make sure you remember what your theorems are. You got the hypotenuse leg, you got the angle, side, angle, 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 side, 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 and side, angle, side. Okay, so this is proving triangles congruent. Again, I want to thank you for checking out my video. Have a nice day.